Okay, this next section is on another method to solve called completing the square. Before we get into that, I just want to review a couple of things. Right here, it says to multiply. Now, x plus 2 squared, that means write 2x plus 2's and multiply those guys out. And of course, you remember that means FOIL. X squared plus 2x plus 2x plus 4. Combine like terms, and you get x squared plus 4x plus 4. This is what's called a perfect square trinomial. And that's because it came from something squared. It's got a squared here and a squared here, and then the middle thing follows the pattern that it's supposed to with multiplies to here, adds to there. This guy over here, x squared minus 6x plus 9, it says to factor. All right, two numbers that multiply to 9 but add to negative 6, not 1 and 9, so it's got to be 3 and 3. In fact, to get negative 6, they're both negative. So it factors into x minus 3, which can be written as x minus 3 squared. This is called a binomial squared. So the relationship between these two things is if you have a perfect square trinomial, right? Perfect square here and here, then it can factor into a binomial squared. All right, now why do we care about that? Well, we just talked about the square root method, where if you had stuff squared equals a number, then you can get rid of that squared by taking the square root to both sides. And then your answer, these canceled, so you're just left with x minus 2 equals, now the square root of 16 we know is 4, but remember that there's a double answer with square roots, and there's always a plus or minus right there. And then you just have to finish from there. You would add 2 to both sides, so you get x equals 2 plus or minus 4, which is 2 plus 4, and 2 minus 4, which is 6 and negative 2. So all three of these things are related, and that's where this idea of completing the square comes in, is we're going to turn all of our trinomials into a perfect square trinomial so that we can then factor them into a binomial squared so that we can then solve our equation by taking the square roots of both sides. All right, let's look at the steps. So first step is to get the equation equal to 0. Now you're going to see me moving a lot of stuff back and forth. I just always follow these same steps and get it equal to 0 first. So first example here, check. We're equal to 0. Okay, next step says to divide everything by any number in front of x squared so that it's in this form. All right, we already have a 1 out front, so I'm in that form, right? X squared plus bx plus c. B is right here, negative 6, and c is right here, negative 13. Now you're going to move the constant, that's c, over to the other side. So like I said, you're going to be moving a lot of stuff back and forth. I might have already just moved this back over here, but just follow these steps and it'll help you walk it through. It'll help you walk through the whole process. Notice I left a space there. That might trigger some memories for you guys. You're going to add this right here. Now this is the thing to remember. It's a formula that you should commit to memory. B over 2 squared. You're going to add that to both sides. So here's B. B over 2 is 6. It's technically negative 6 over 2. But we square that. That's negative 3 squared, which is 9. You're going to add 9, and then you're going to add 9 over here as well. So right now our equation looks like this. X squared minus 6x plus 9 equals 22. Okay, now what we just did was on this left side, we turned this equation into a perfect square trinomial. Remember on that last page, this x squared minus 6x plus 9, it factored into, very easily, x minus 3 squared. Now some things to point out there to make sure that you recognize them. Notice that this number inside here is the same number that's inside there. The 9, of course, or sorry, the 22 comes from, gets brought down. The 22 comes from the original number plus 9. You have to add that to both sides. And then once I've got it to here, it's a simple method to solve. I'm going to do just like before. I'm going to square root both sides. That cancels this thing. Now I'm at x minus 3 equals the square root of 22, but not just the square root of 22, right? Plus or minus. And then to finish solving, add the 3. Remember, anything you add to the other side should go out in front of that plus or minus, so there's no confusion over what it is that's positive or negative. And that right there is the solution. Now, you couldn't have found that by factoring. If you look back at this original example, x squared minus 6x minus 13, you can't find that by factoring. There is no two numbers that multiply to negative 13 but add to negative 6. That's where this completing the square method comes in. Okay, next one. All right, this one we're going to start with moving the 45 over. Again, it might seem like a weird process. Just do it this way, follow along. You might get to where you don't need to do this step, and that's fine, but for now, just follow my process. Okay, then it says to divide by any number in front of x squared. So I'm going to divide by 5, and our goal is to make sure that it divides out of everything. And the examples that you're given, it should divide out of everything, because we don't want to deal with fractions. I almost said we don't want to deal with fretzels. I don't even know where that came from. Okay, now we're down to here. Much easier to deal with, right? Now this happens to be one that you could factor, but we're not factoring, we're practicing completing the square. So our next step is to move c over to the other side. Okay, now we're at x squared plus 8x. I like to leave a blank because I'm going to be adding something onto there. Equals 9. Okay, I got to do my calculations over here to the side. I need b over 2. In this case, b is positive 8. So that's 8 over 2 squared, or positive 4 squared, which is 16. But don't forget to add it to both sides. That's the mistake I see happen a lot. Okay, now we're at x squared plus 8x plus 16 equals 25. Right? Now we've completed the square on this right here, right there. We've completed the square, meaning that is a perfect square trinomial. So it will factor straight into a binomial squared with an x and a 4. And it's positive 4, but something else to notice is this sign will always be the same sign as right there, always. So if you don't have to worry, if you don't want to have to worry about whether b is positive or negative, you don't have to. You just have to keep that sign the same. All right, now it's just a matter of solving. X plus 4 squared equals 25. We know how to get rid of squared by square rooting. Those are going to cancel. So this side is x plus 4. This side is plus or minus 5. Do not forget the plus or minuses. Minus 4, x equals negative 4 plus or minus 5. That gives 2 answers. We can combine them because nobody's in jail. Negative 4 plus 5, negative 4 minus 5. That gives us 1 and negative 9. And there's our solutions for x. So when there's a radical, those are irrational solutions. You'll see that in your assignment. It'll say stuff about irrational and rational. Irrational means there's going to be a radical left over. These are called rationals. No radical involved is basically the difference between them. All right. Let's try this next example. So it's already set equal to 0. Check. That step is done. So now I'm going to move C over. This is C. That's B. So I'm going to add 10. As is, you can't factor that, right? Notice that this method can be used when it's not factorable. But you do want to make sure that this b right here is divisible by 2 because that's that next step, right? B over 2 squared. And if you end up with a fraction in there, it's not always the best thing to pick. So I'm adding 4 to both sides. That's this guy right here. All right, this, I've set it up this way. I added this specific number. That blue number right there was the specific number that would turn this side into a perfect square trinomial, which means it factors into a binomial squared. The number that goes in there is whatever you had before you squared, or half of this, and the sign always remains the same. All right, then on this other side, we've got it equal to 14. And we did this so that we could solve it easily with square roots. So I'm going to square root both sides because it gets rid of that. This side is x plus 2. This side is plus or minus square root of 14. Now 14 is just 2 and 7, so we won't have any homies to break out there. And to finish solving, we subtract 2 from both sides. X is equal to negative 2 plus or minus square root of 14. Can't go any further. 2 is on the outside of gel, 14 is on the inside, so that one's done. Okay, next one. Okay, equal to 0, check. Add 5 to both sides. Got x squared minus 8x. I'm going to leave a blank because I'm going to add something to both sides. It is always add, by the way. You're always adding that b over 2 squared term. Always. It's the only way to get a perfect square trinomial is if that last one is a plus. Okay, so now I'm going to figure out what to add to both sides. So b over 2 squared, that's 4 squared, or 16. So plus 16 plus 16. All right, this side, I set it up so it factored into a binomial squared. It's going to have an x and a 4, and this says that there's a minus inside there. The 4 came from right here. That equals 21. Again, square root both sides to get rid of the squared. You're left with x minus 4 equals plus or minus square root of 21. 21's 3 and 7, no homies. Nice simple example of an irrational answers.